Okay, we are going to talk a little bit about plate tectonics. For Unit 4's jumps around a lot, and I've reorganized it many, many times. But we talk about plate tectonics in this order because I want to be able to talk a little bit about what causes soils to form, and that's really what the focus of Unit 4 is on. So, as we talked about at the beginning, here is the objectives and essential knowledge and skills. Describe the geological changes and events that occur at convergent, divergent, and transform boundaries. It's important that you understand these different boundaries because there's definitely going to be questions on the AP exam that ask you to apply your knowledge of what happens at each of those boundaries. So it's important to remember, and I'm hoping most of you took Earth Systems. If you didn't, make sure that you take the time to look in the textbook, read a little bit about this. But the Earth structure is made of, if we go from the center to the outer part, the core is made of solid nickel, iron, and other radioactive elements. It creates this massive amount of heat within the Earth's core. The mantle is a liquid layer of magma that surrounds the core, and it's maintained as a liquid form because of the intense heat of the core of the Earth. Um, the asthenosphere is the solid, flexible outer layer of the mantle. So that's like um, right below where we live. Okay. And then the lithosphere is the brittle layer of rock that floats on top of the mantle. That's where we have our tectonic plates. So the asthenosphere is like a little bit more solid. I think of like oh, I'm trying to think of like something that you'd use that's a little bit more flexible, okay? Not liquid, but flexible. That's beneath that lithosphere that allows the plates to move. Um, the lithosphere is more brittle, it's more rock, and then the crust is the outer layer. That's the Earth's surface. That's where we live. So the core, the mantle is liquid, the asthenosphere is a solid, flexible layer and the lithosphere is more brittle, more like rock, and then the crust is the very outer layer of that lithosphere where we live. These structures or these like parts are important to understand because when we talk about the plate boundaries, there's three major plate boundaries that you need to know. The first one's a divergent plate boundary, and if you read the book Divergent, it means two like separating or different. So the divergent plate boundary is where two plates are moving away from each other. Because of that, you have this magma plume or this area of magma that can rise up as those plates are um, moving apart from each other. This can cause mid-oceanic ridges. It can cause volcanoes. It can cause seafloor spreading and rift valleys, which are on the land. The mid-oceanic ridges and the seafloor spreading obviously occur in the ocean. So divergent boundaries is when you have two plates moving away, and we'll do some activities to sort of reinforce these ideas. The convergent plate boundary is where the two plates come together or converge. The plates are always going to lead to move towards each other in convergent boundary areas. That leads to subduction. One plate is going to be forced beneath another plate, and the oceanic plate is usually going to be the one that's subducting because it's um, has more iron in it, so it's heavier. So it's usually the one that's subducting. At these convergent plate boundaries, you're going to see mountains, island arcs, earthquakes, and also volcanoes. So convergent boundaries and divergent boundaries, you're seeing some similar things, but this is where we get the formation of mountains and islands, and then you'll still have volcanoes. You can have earthquakes as that one is sliding underneath. Um, and then the volcanoes, because during that slide, you can have magma that rises up in between those two plates. And then the transform fault boundary, also known as a slip strike boundary, those two plates are going to move past each other like this. Basically, the pressure builds up because they're sort of like stuck on each other. And as they're sliding, it's happening really slow and they get stuck on each other. And when we have an earthquake, basically it slips and that energy gets released really, really fast. So those are the three plate boundaries. So divergent, convergent, and transform plate boundaries, also known as slip strike boundaries because they slip past each other. So, underneath the Earth's crust, underneath that asthenosphere and that lithosphere, we have this convection cycle. That's what causes those divergent plate boundaries because as the magma rises, because remember, hot air, think of in your house, hot air rises, right? As the magma that's really hot rises to the surface, it starts to cool. And as it starts to cool, it starts forcing those plates apart because the cooled magma is a little bit gets a little bit bigger, okay? It expands. And so because of that, it pushes those plates apart from each other. So in one area, as you can see on the diagram here, it's pushing the plates apart. And then once it gets to the continental crust, you're going to see that oceanic crust sinking back below the continental crust. As that magma that reaches the earth solidifies and cools, it's going to create new lithosphere. That's what causes that seafloor spreading. And that spreading magma is also going to force that oceanic plate to subduct under the continental plate. That sinking oceanic plate is going to turn back into magma. And it creates these force of crust actually gets pushed up because as you're forcing the one under, this one's sort of pushing back up. So this convection cycle, we're going to talk about convection in the atmosphere. We're going to talk about convection, obviously in the magma, but these are important concepts to understand because it's going to impact multiple things. Okay, excellent. So in convergent boundaries, there's a couple different ways that these things can happen. You can have an oceanic plate connecting with an oceanic plate. One plate's going to subduct under another. That's going to force magma up to the surface, forming mid-ocean volcanoes and island arcs. It can also create what we call like an offshore trench, which is where the one plate is subducting under the other plate. The next one is the oceanic to the continental. That denser oceanic plate is going to subduct, like we talked about already. The plate's then going to melt and turn back into magma. That forces the magma up towards the surface, and that's what's created our coastal mountains, things like the Andes Mountains and volcanoes that occur on land. This can also cause tsunamis because as that plate subducts, it could create an earthquake, and tsunamis are an effect of an earthquake. And the last one is a continental to continental. One plate is going to subduct under another one. That's going to force the crust upward, creating a mountain range. That's how we formed the Himalayans. Or the Himalaya mountains. So convergent boundaries are always going to be like a subduction zone. And depending on what type of plates are connecting, it's going to impact what's happening at those plates. Transform fault boundary we talked about. That is because those plates are sliding past each other. It creates a fracture in the surface. Earthquakes are the most common thing that happen here. And that's because, like I said, those rough edges of the plates get stuck on each other and the pressure builds. The plates try to keep sliding, but the pressure sort of builds up over time. And when the stress becomes too much for that fault to hold, then they're going to slide past each other and release energy. And that's what shakes the surface of the earth, the lithosphere. The location of that earthquake is called the epicenter. The focus is sort of where, like below the earth, that is occurring. All right. So transform fault boundaries, you're not going to need to know like epicenter and things like that, but just know that when those things happen, they release that energy, and that can cause devastation for lots of other reasons. So things like tsunamis, we talked about on the previous slide. Also, devastation in ecosystems can also come from transform fault boundaries, um, releasing that energy. When you look at the tectonic plate map, you should be able to predict what's going to happen in certain places. The Ring of Fire is the pattern of volcanoes that you see all around the Pacific Plate. So this here is the Pacific Plate. The Ring of Fire, you've got volcanoes all across this Ring of Fire here. And then you also get offshore island arcs like Japan, what's around Japan. Transform faults are where we see locations of earthquakes. So that's these here. All right, these transform. And then the hot spots are areas of magma that are rising up to the lithosphere. That's what causes islands that are in the middle of the ocean, like Iceland and Hawaii. So you can sort of predict what might happen in those places based on the type of plates that are connecting to each other. Okay, so for your response notebook or in your notebook, explain how subduction can lead to volcanic activity. All right. And think about the impacts then also of volcanoes. What happens when a volcano erupts? What are some of the ecological impacts of that? Okay. That's not part of the question, but think about that because that's something else that you'd have to sort of apply. Okay, that's it for me today. Have a great day, everybody, and I'll talk to you later.